Welcome to The Explainer. Today, we're tackling something that might look a little intimidating at first, polynomial long division. But trust me, once you see the pattern, it's actually super straightforward. We're going to break it all down step by step.
So, before we dive into all the x's and y's, you might be asking, why do I even need to know this? Well, it turns out polynomials are a huge deal, especially in the real world. Think about physics. Anytime you want to figure out the path of a basketball shot or, the trajectory of a rocket ship, you're actually using polynomials. So getting a handle on this stuff, it's the key to unlocking some seriously cool science.
Okay, so you've probably gotten the hang of adding, subtracting, and even multiplying polynomials, right? But what happens when you need to divide them? Yeah, that's the one that's a little different. It needs a special, really structured process to make sure everything stays neat and tidy. All right, here's our game plan. We're going to start with the basics of long division, stuff you already know. Then we'll apply that to polynomials. I've got a great pro tip about placeholders, we'll talk about remainders, how to check your answer, and we'll wrap it all up with a simple checklist. Okay, first things first. Let's start with something you're already familiar with. We're going to rewind the clock a bit and do a quick refresher on something that is the absolute bedrock for all of this. Good old numerical long division. Look familiar? This is the classic setup, right? You've got your dividend, 875. That's the number we're dividing, tucked inside the little house. And the divisor, 25. That's the number doing the dividing, sitting right outside.
You know the secret to all of this, whether we're talking about numbers or polynomials, is just this simple, repeating four-step cycle. That's it. Divide, multiply, subtract, bring down. We're just going to do that over and over again until we're done.
Okay, let's kick off the cycle. Step 1, divide. We're not looking at the whole 875 yet, just the first part. So, how many times does 25 go into 87? Well, it goes in 3 times. Easy enough.
All right, next up, we multiply. We take that 3 we just put on top, and we multiply it by our divisor, 25. That gets us 75, and we'll write that right underneath the 87. And now for a really key step, subtraction. We just subtract that 75 from 87, and yep, that leaves us with 12. See? Simple. And to finish off our first go-around, we bring down the next number. That's the 5. So we bring it down next to the 12, making it 125. And guess what? We're all set up to start the cycle all over again. So we do it again. Divide 185 by 25. That's 5. Multiply 5 by 25. That's 125. Subtract. And we get 0, no remainder. So our final answer, the quotient, is 35. Done. Okay, that was a great warm-up. Now let's get to the main event, applying this to polynomials. And here's the best part. It is the exact same process. We're just throwing some variables into the mix. Okay, now check this out. This is what's so cool. Look at the setup on the left for numbers, and then look at the right for polynomials. See? It's practically identical. You've got your dividend inside, your divisor outside. The whole structure is the same.
So let's start the cycle. Step 1, divide. Now here's a little trick with polynomials. You only need to focus on the first term of the dividend and the first term of the divisor. So what's x squared divided by x? It's just x. And that's the first part of our answer, so we'll write it right up top. Okay, on to steps 2 and 3. Multiply and subtract. We take that x we just found and multiply it by the whole divisor, x plus 5. That gives us x squared plus 5x. Now, this next part is maybe the most important part of the whole process. We have to subtract that entire thing. Putting it in parentheses is a great way to remember that you're subtracting both terms. So x squared minus x squared is 0, and 9x minus 5x gives us 4x. Great. To finish the cycle, we bring down that plus 20. And just like before, we start all over again. We look at the new first term, 4x, and divide it by our divisor's first term, x. Well, 4x divided by x is just a positive 4, so we'll add that to our answer up top.
Okay, I want to show you a pro tip for a situation that comes up all the time. This is where staying organized is absolutely everything, and it's where a lot of people make little mistakes that are super easy to avoid.
So here's the deal. If your polynomial is missing a term, like it jumps from an a cubed straight to a constant, with no a squared or a term, you need to put in a placeholder. Think of it like this. It's a term with a 0 in front of it, like 0a squared. It's just like when you're doing addition and you keep all the 1s, 10s, and 100s lined up in their columns.
This does the exact same thing for your variables. And this image shows it perfectly. The original problem was just a cubed plus 27. See how it skips over a squared and a? So to keep our columns neat and tidy, we just slot in a 0a squared and a 0a. And look at that, now everything is perfectly lined up. This one little trick, I'm telling you, it prevents so many simple mistakes.
Okay, so what happens when things don't divide perfectly? I mean, it happens with regular numbers, right? And it's the exact same story with polynomials. Sometimes you're just left with a remainder.
So what do you do with it? It's actually really simple. Whatever's left at the very end after your last subtraction, the bit that's too small to be divided anymore, that's your remainder. And you just write it as a fraction, with the remainder on top and the original divisor on the bottom.
Now this might be my favorite part, because with long division, you never ever have to be unsure about your answer. There is a 100% foolproof way to check your work every single time.
And here it is. All you do is take your final answer, the quotient, and multiply it by the thing you were dividing by, the divisor. Then, if you had a remainder, you just add it on at the end. And if you did it all right, it will equal the exact dividend you started with. It's a perfect way to know you nailed it.
All right, to wrap this all up, let's make a quick checklist. This is your step-by-step guide. If you follow these steps for any problem, you'll be in great shape.
Okay, here it is, your 5-step game plan. Step 1. Make sure everything is in standard form. That just means highest exponents first. Step 2. Look for any missing powers and pop in those 0 placeholders. Super important. Step 3. Start the cycle. Divide, multiply, subtract, bring down. Step 4. Just keep repeating that cycle until you can't divide anymore. And finally, Step 5. Check your answer. That's the best part. Multiply your quotient by the divisor, add the remainder, and make sure you land right back where you started.
So really, what's the big takeaway here? Polynomial long division isn't just some abstract math rule you have to memorize. It's a really powerful, organized process. And once you master it, it's not just about acing your next quiz. It actually opens up a whole new world of more complex problems you can solve, in things like physics and engineering. So now that you have this tool, what kinds of problems are you going to tackle?